All right, let's just address the elephant in the room. You've got your Java exam literally tomorrow. You have maybe 2 hours left to study, and you are opening this course material for the very first time. Hey, take a deep breath. I know the panic is setting in, but you are exactly where you need to be. Welcome to this emergency explainer. I'm going to be your coach today, and we're going to get through this together. We're skipping all the filler and focusing absolutely exclusively on the highest yield Java concepts you actually need to pass tomorrow's exam.
Look, I see you and your stress right now. It's completely justified. When you're crammed for time, cognitive overload is absolutely your worst enemy. So we are officially instituting the triage rule right here, right now. We're cutting the fluff. We are only looking at what's actually going to show up on that test, pulling directly from past paper questions and course study guides.
Here is our exact roadmap to save your grade. First, Java and JVM mechanics. Second, primitives versus references. Third, the syntax rulebook. Fourth, arrays in memory. And finally, a rapid-fire exam drill.
Let's kick things off with Section 1, Java compilation in the JVM.
So here's how the life cycle actually works under the hood. It's a linear process. Step 1, you write your human-readable source code in a .java file. Step 2, the compiler, which is called javec, transforms this into an intermediate format called bytecode, saving it as a .class file. Step 3, the Java Virtual Machine, or JVM, reads that bytecode. And finally, Step 4, the JVM translates it into the native machine code of whatever specific operating system you're using. So the absolutely crucial point here for the exam is this. The JVM never ever sees your source code. It only sees that compiled bytecode.
And honestly, this is exactly why Java is famous for its write once, run anywhere superpower. It's a concept called architectural neutrality. Your bytecode doesn't care about your hardware. It's just an abstract, platform-neutral instruction set. Each operating system has its own specific JVM implementation that handles that final translation. Now, the trade-off here, and they love asking this on exams, is that Java sacrifices a little bit of raw speed compared to natively compiled languages like C, all in exchange for this true platform independence.
Now, when you're actually writing this stuff, your Integrated Development Environment, or IDE, is a massive lifesaver. Tools like IntelliSense pop up with real-time suggestions for methods and variables, and syntax highlighting color codes everything so you can actually read it. But more importantly, you have to know how to use the debugger to isolate logic errors. Setting a breakpoint pauses your code's execution, which lets you use the variable watch window to see exactly what your data is doing step by step. Just watch out for what I call the recompile trap. If you edit your code and just hit run without ensuring it recompiled, the IDE might execute the old, stale bytecode. It's a massive trap. You'll be staring at your watch window thinking your bug fix failed when really your new code was never even compiled.
Moving right along to Section 2, primitives versus reference types.
Okay, this is where so many students lose easy points. There's a massive difference in how these are stored in memory. Primitive data types, like saying int x equals 5, store their raw values directly in memory. They're fast, they're basic. Reference types, on the other hand, like a string, an array, or a custom object, do not store the data directly in the variable. Instead, they just store a memory address, basically a pointer that leads to where the actual object lives on the heap.
Let's put this into a real exam scenario. If you declare an array of primitive integers like int bracket bracket r, it stores those raw numbers directly in a contiguous block of memory. It's fast and super efficient. But if you use a wrapper type array like integer bracket bracket r2 with a capital I, you aren't storing numbers directly anymore. You're storing references, those pointers we talked about, to separate, individually allocated objects on the heap. So, keeping it to primitive arrays uses way less memory and is significantly faster.
Which leads us to a massive, massive trap, reference aliasing. Say you have an object P1 and you write P2 equals P1. You are not duplicating the object. Actually, scratch that. Let me be super clear. You are only copying the reference. Both variables now point to the exact same physical object in memory. So if you change a value using P2, you just changed it for P1 as well. Burn this concept into your brain for tomorrow.
All right, Section 3, the syntax rulebook, control flow and exceptions. Let's rattle off the core flow rules you need for the multiple choice section. Sequential flow is just line by line. Selection uses if, else, and switch to make choices. Iteration uses for, while, and do-while loops to repeat code. And jump constructs use break, continue, and return to immediately alter the flow. But listen up, pay really close attention to short-circuiting. For logical operators like the double ampersand for and the double pipe for or, Java guarantees it won't even evaluate the right side of the expression, if the left side already determined the final outcome. It's a classic trick question. Next up, we have exceptions. Basically, this is when your program's normal flow gets completely derailed. The hierarchy splits them into two main buckets. Checked exceptions are problems the compiler literally forces you to handle, like trying to open a file that's missing. Unchecked exceptions are severe runtime problems, essentially logic bugs on your end, like trying to access an object that is null.
You need to lock these 4 rules in right now. First, the try-catch block is how you handle exceptions safely. Next, the finally block absolutely always executes, whether an error happened or not. Professors love testing that one. You use the throw keyword to deliberately trigger an exception yourself, and look out for common runtime errors. If you did a null pointer exception, because a reference points to nothing, run a quick debugging scenario. Drop a breakpoint before the crash, and check your watch window to see exactly which object didn't instantiate. Oh, and also watch out for arithmetic exception. That's usually from trying to divide by 0.
Almost there. Section 4, Arrays and Memory Management.
So an array is just an indexed, contiguous collection of memory holding multiple values of the exact same data type. 2 huge takeaways for tomorrow. First, the index always, and I mean always, starts at 0, not 1. And second, because arrays are technically considered objects in Java, you have to use the new keyword to actually allocate memory for them during initialization.
And right on cue, the array assignment trap. It's just like the object reference trap we talked about earlier. If you write int array b equals a, you are performing absolutely 0 element duplication. You are just copying the memory address. Both a and b now point to the exact same array in memory. If you modify b index 0, a index 0 changes too. Do not let them trick you with this in the code tracing questions.
All right, time for the final sprint. Section 5, Rapid Fire Exam Drill.
You've survived the core concepts. Now let's test it with a simulated rapid-fire drill using actual past paper questions to build up that immediate confidence. Question 1, straight from an old exam. Why does Java use an intermediate bytecode stage instead of compiling straight to machine code? Think back to what we said about architectural neutrality. Lock in your answer?
Got it? The answer is, it decouples the compiled program from any specific CPU or operating system, trading some raw speed for total platform portability. If you got that, you're already doing great.
Boom, next question. Let's test those primitive types. Which data type is used for a single character, and which one specifically stores true or false values?
The answer? You use char for a single character and Boolean for true or false. Those should be totally free points on your multiple choice sheet.
Last quickfire question, hitting basic syntax and operators. What is the value of 10 plus 5? And which exact operator is used for a logical AND? The answers are 15, and the double ampersand is used for logical AND. And just like that, you made it through the triage. You are totally ready for this. If you take away just one single rule for tomorrow from this entire explainer, please remember this: Java passes references, not objects. Keeping that straight will literally save you on half the logic questions. So take a breath, get some rest, and go absolutely crush this exam. Oh, and what other sneaky topics are hiding in your syllabus just waiting to trip you up? Well, we'll find out next time.